Kia ora koutou. This is another video from a student request. This one is also from Aaryan, and it's a good question on integration again. This time we've got an improper integral. We're told what substitution to do. So we're told to use the substitution u equals root x, and then we have to find the exact value. Now, the thing that probably made some of you freak out is this top limit of infinity. Remember that we did improper integrals back in AS, and we really don't need to stress too much about this. I'll go through how to approach that limit in a few minutes. If you find this question hard, it is probably because you haven't done enough work yet on chapter 8. So make sure you've done exercise 8C and used all of the worked solutions that are up on Google Classroom for it. Okay, let's have a wee look. Right, well, we're going to start off by saying let u equal x to the power of a half. Now we're slowly going to replace everything in this to get it in terms of u. We know that u squared will be equal to x, and so u squared plus 1 will be x plus 1. Now, that means that we've switched out this, and here we've got a u for the root x. Let's differentiate and see how we're going to deal with the dx. So du by dx is equal to a half x to the negative a half, which is 1 over 2 root x. That means that we have du is equal to 1 over 2 root x dx, or 2 du is equal to 1 over root x dx. Now, the reason that I want to do that is this. I've got root x here, and I've got dx here. The last thing we have to do is to change the limits over. So using our table, our x limits are infinity and 3, and u is equal to the square root of x. So the top limit will still be infinity, right? So you can think of this one here as the limit as x is going to infinity, right? And this one here will still be going to infinity. The lower limit is going to be root 3. Now we're good to go. So going from the start, we've got the integral of this with respect to x is equal to the integral of 1 over u squared plus 1 times 2 du. And that should make you feel very happy because it's a tan inverse integral. So here we've got 2 tan inverse of u, and we're going to evaluate that as the limit as u goes to infinity here, and the lower limit will be root 3. So this is probably a good time to think about what that tan inverse graph looks like. Remember that this is my graph of tan theta. And for all of my trig integrals, when I'm finding the inverse, I need to be isolating my tan graph so that it's passing both the horizontal and the vertical line test. In other words, the function that I'm going to use for the inverse has to be 1-to-1. So it's no good using all of that tan graph with lots of x values. We just want to chop it down to just this bit here. We've lost our axes. Right, so when I take my inverse, I'm limiting in here. My domain is going to be negative pi on 2 up to pi on 2. That's going to be my range in my inverse function. And my range in f of x will become my domain in my inverse function. If you're finding that tricky, you need to go back and watch some of the old AS videos on how to find inverses. And I put the graph of that over here for you to show you what it looks like. So this is the tan inverse graph, and you can see that it's the reflection of the relevant part of the tan graph in the y equals x axis. But it's easier when you're working with tan inverse just to say the angle whose tan is this, right? So let's back up a little bit and say that here we've got 2 times the limit as u tends to infinity, tan inverse u, minus 2 times the angle whose tan is root 3. in here, what angle is going to give us a tan of infinity? Well, that's going to be 2 times pi on 2. So you don't have to draw the tan inverse graph to do that. You can just use your basic graph and think about what tan inverse means. Right, so looking in here, what value of the angle is going to give me infinity up here? So that's where the pi on 2 comes from. And then to find tan inverse of root 3, as usual, we go to our special triangle and we say that this angle here of pi on 3 will work. So it's 2 times pi on 2 minus 2 times pi on 3, which gives me pi minus 2 pi on 3 for a final answer of pi on 3. So there you go. So I think that's an example of a question that looks quite intimidating, but if you just go step by step, it's fine. Make sure that you're confident with what I've done there with the limit being infinity, right? We just replace it with the limit of x as x goes to infinity, and we work like that. Happy to talk about those more when I see you in class. Thanks for watching. I'll do some more videos later on tonight.